Hey guys, so in this video we're going to be going over IXL section U10. I hope you guys are doing well. Make sure you get a copy of these notes and you fill them out as we go through it. I'll be writing them down on here as we go. As well, so notice this is going to be working on section U10, and our quiz is ultimately going to be on section not only U10 but also U8. We learned that last class, and U9 and then U11. So if you want, after you get this done, I encourage you to go ahead, try out U8, U9 and U11. Those are going to be working on word problems. So anyways, let's go ahead and get started on this. My recommendation, work on U9 and U11 after you do this section. Alright, so I'll go ahead and read this out loud. You can follow along with me. So another creative method for solving systems of equations, aka multiple equations, is through a process called elimination. Elimination takes advantage of similar structures in equations, using them to eliminate variables in an equation, thus allowing us to solve for a single variable. The goal is to combine equations in such a way that one variable is entirely blank, right? And so go ahead, think about the name that it's called. What do you think is going to go here? Well, it is entirely eliminate. Right, and that's why we call it elimination. The idea is we're going to take advantage of the similar structure and use it to eliminate one of those variables. Now, how do we do it? Well, we can look at this diagram right here. If we're given equation 1 and equation 2, the idea is that we can actually just add these things together. Now, why can we do that? Well, it's because they're equations and they both equal the same thing, and adding two things that are true together still creates a true thing. So we can add these together and that's fine. And so watch what happens when we do, right? If we add these things together like we do right here, you're going to notice our two y's are going to cancel, right? We have a 2y and we have a negative 2y. We know that's going to add to 0, so we can actually add both these equations together, knowing that these will cancel, and then out we will get 9x plus 6x. That'll make 15x right there. And then 6 plus 14, that's going to make 20. And we get that right there. And these two things, right, that is where the elimination was happening. They canceled each other. Okay, so we do that and then it creates an equation that we can go ahead and solve for. Notice once we were done with it, we had 15x equals 20. One variable, it's not too hard to solve for that. Okay, so note sometimes we will have to multiply an equation so that its variable will perfectly eliminate with the other equation. So basically, they don't always come perfectly prepackaged. To do this, simply multiply the entire equation by the number that would make your variables perfectly, and again, eliminate. Okay, so we would find that number that multiplies, multiply the whole equation by it, and then we could go ahead and combine them to eliminate them. Once a variable has been blank, well, eliminated, we can solve for the remaining variable. Remember, solutions to a system of equations are coordinate points, so there will always be a blank and a blank. So remember, coordinate points are going to always have an x and a y in your solution, or coordinate point xy. Okay, so step 1, identify variables that could easily blank with each other, right? That's going to be eliminate. Remember, we are combining equations to eliminate a variable. If necessary, blank an equation so that the variable will perfectly eliminate with other equations. So remember, we have the ability to multiply these. And we can use that to our advantage to do elimination. Step 3, combine the equations to eliminate the desired variable. Step 4, blank for the remaining variable. So after we've eliminated, we should only have one variable left. We can go ahead and solve for it. And then 5, back solve for the other missing variable. So remember, we have 2 coordinate points. Just because we find one variable, well, we still have to find the other one. So, alright, so here is our first example. So remember, the idea is that we want to combine these in a way that the variables will eliminate. So what I'm going to look and notice is that this has a y and this has a y. Now what can I do with that? Well, I'm going to use those and actually take them away from each other to eliminate them. Right? Meaning that if I took this equation right here and I eliminated it from this equation right here, or I took it away from there, these y's would cancel out. So all that means is I'm just going to subtract the first equation from the second equation. Okay, and so we see that happen right here. So we're going to go ahead and just do some subtraction. 3x minus x, that's going to make 2x. Y minus y, those eliminate and they go away. And 4 minus 8, remember 4 is positive, minus 8 would be negative, so that would make a negative 4. Okay, and that's our equation, right? And notice it's pretty simple now. We just have 2x equals negative 4, and that's not too hard to solve for. We can divide by 2 on both sides, and we will get x is equal to negative 2. Just like that. Okay, but remember, we are not done. We do need to go ahead and back solve for that other variable. And this is not too hard. We're just going to pick our simplest looking equation and plug in the solution that we've already found. So I'll go ahead and take this one. It looks the simplest. And x is equal to negative 2. So I write negative 2 plus y is equal to 8. All right, we want to find out what y is. So we add 2 on both sides. Those will cancel, leaving us with y equals 10. Okay, so that's our coordinate point, negative 2, comma 10. Alright, just like that. Remember, the main idea was noticing the similarity, and that we could take this away from here to eliminate these two. Okay, example 2. Alright, so again, we're looking to do some elimination, and the best part about this, right, the best part about elimination is that it takes advantage of equations that look very similar. And so what looks similar about this? Well, it's the 4x and the negative 4x. And we notice those are both perfectly opposites of each other, and that's good because I can just add these together and they'll go away. So I'll add these equations, and negative 4x plus positive 4x, that'll make 0. They eliminate and they go away. I'll then have negative 10y plus 9y, that will make negative y. And then I'll have negative 20 plus 14, and that's going to make negative 6. Okay, so and again, notice, right, this is pretty simple. We're one step away from our first solution. We just need to go ahead and get rid of the negative. One way to do that is to divide by a negative 1, because remember, dividing by a negative will get rid of a negative. And we will have y equals negative 6 divided by negative 1. Remember, negative divided by a negative makes a positive. And that's our first solution. We'll now go ahead, take the simpler looking of these two equations, and back solve for a previous variable. So we'll have 4x plus 9, and we said y is equal to 6, which equals 14. So a little bit of work here, but not too much. 9 times 6 is 54, which equals 14. And 4x just drops down. We will subtract 54 from both sides. Remember, we're working in reverse PEMDAS order. So 14 minus 54 is going to make negative 44. And 4x is equal to negative 44. We're going to go ahead and divide by 4. And we will get x is equal to negative 11. Okay, and that's our solution, right? It's the coordinate point negative 11, comma 6. Okay, let's go on to the next one. Alright, so same deal on this one. We're going to look for similarities that we can use to go ahead and get rid of some of our variables. Now, when I look at this one, I'm going to notice that neither of these variables are exactly equal to each other, right? Nor are they exactly opposites. So, right, the negative 6x, the negative 2x, they don't perfectly cancel or eliminate. So, they do have similar structures, which I'm going to take advantage of. However, they don't perfectly eliminate, so I'm going to have to do some multiplication. So, I will go ahead, and what I'm actually going to do is multiply this bottom equation by 3. Okay? When I multiply that bottom equation by 3, and maybe you see what's going to happen, and I'll go ahead and write them all over here, right? As I multiply that bottom equation, it's going to make it so it equals the top equation, or at least my x's match up. So I will get negative 6x right there, right? Because notice everything was multiplied by 3. And then negative 3y, and 3 times negative 12 is going to be negative 36. Okay, so notice the main idea here was that I scaled this up by 3 in order to get these variables to match each other. Because now I can just go ahead and take them away from each other, or subtract them away from each other, and they'll eliminate out with each other. So negative 6x minus negative 6x, well, it's one thing minus the same thing, it just goes to 0. Negative 10y minus negative 3y, remember minus a negative makes a positive, so negative 10y plus 3y will make negative 7y. And then over here, 20 minus negative 36, well, minus a negative makes a positive, so this will be 56. Okay, and we're almost there, right? And notice even when I had to do some scaling up for elimination, the process was still pretty straightforward when they have this similar structure. So we'll go ahead and finishing this equation, we divide by negative 7 on both sides. And we'll get y is equal to 56 divided by negative 7 is going to be negative 8. And that is y. Okay, so remember we do have a second variable. We got to go ahead and solve for that. So I will go back over to here, and I'm just going to take this bottom equation right here and use that to back solve for x. So I'll have negative 2x minus, and remember y turned out to be negative 8 equals negative 12. Okay, so got to do some simplification, got to do some algebra, but that's what we're here for. So we simplify that, it becomes a positive 8. We'll go ahead and subtract 8 from both sides. That will cancel, negative 12 and negative 8. That is going to make negative 20. And then negative 2x, now we want to divide by negative 2. So we see that x will be equal to 10. Okay, I got a little bit cramped, but notice we just divided by negative 2 on both sides. That's how we got rid of that. So our coordinate point is x, x is negative 10. So negative 10, comma, oh, my bad, it's a typo, it's not negative, it's positive. 10, comma, negative 8. Alright, and let's go on to the very last problem. Alright, so same deal on this one. We're going to be looking for something for similarities in here that can eliminate out with our variables, right? We want to look for similarities in the variables that could then be eliminated. Now, again, we don't see exact similarities, but I do see that these y's kind of look like each other. And so I realized that, well, if I were just to multiply this top equation by 9, well, that would make these y's able to eliminate with each other. So I go ahead and I multiply that top equation by 9. So I get out 9 times 3 is 27x. 9 times y is plus 9y. Oops. And 9 times negative 6 is going to be equal to 9 times negative 6 is going to be 54. So negative 54. And then we'll bring over the negative 10x minus 9y equals negative 14. Okay, now notice, right, these actually perfectly eliminate with each other. We have a 9x and a negative 9y. I'm sorry, not 9x, that's supposed to be 9y. Okay, but the idea kind of still stands, right? They are perfect opposites. We have a 9y and a negative 9y. So all we have to do is just add the equations together, and then these will naturally eliminate out. So 27x plus negative 10x, that's going to make positive 17x. 9y minus 9y, those are going to reduce and eliminate with each other. And then negative 54 plus a negative 14. They're both negatives, so they're going to make a bigger negative. And I'm going to get out negative 68. Okay. All right, and we want to find x, so we're going to go ahead and divide by 17 on both sides. And now at this point, I'm referring to my calculator. So I'm just using my calculator to find out negative 68 divided by 17. And I think it's going to be 4, and it is. Okay, so x is equal to negative 4. All right. Notice just some simple algebra. We take advantage of the fact that these can scale to be each other and thus then eliminate with each other. So we found our first variable. Let's go ahead and find our second variable. What happened to that guy? Let's go ahead and move that back. All right, there we go. Okay, so looking for that last variable, I'll go ahead and take this equation, and I'm just going to plug in my recently found variable. So 3 times negative 4, remember we found negative 4 for x, plus y is equal to negative 6. So negative 3 times negative 4, negative 12 plus y equals negative 6. We're going to add 12 to both sides, and we will see that y is just equal to 6. Okay, so we got those solutions out, and our solution now in total is negative 4, 6. Okay, and just to recap, the main idea here is that we were looking for similarities in our equations so that they could be combined or subtracted from each other to eliminate one of our variables. Again, I encourage you to go on to sections U9 and U11. It's going to be the same thing that we've been going over, except structured in word problems. So you'll have to take a situation, make an equation out of it, and then do the processes that we've been looking at right here. Best of luck. Hope you guys are having a great day, and I'll see you soon enough. Bye.